I will give you the formulas for everything that's needed. For example, area, um, unit vectors, the angles in between two vectors, etc. The only thing that I will not provide to you are your identities, which you should know by heart. So let's continue, and we are going to look for the formulas for the area of an oblique triangle, because after all, that's what we studied this semester. And let's see. First of all, let's see our first angle that was given. It seems that I am given angle B. Okay, so let's look at that formula. In order for me to use angle B, it says that I must have sides A and side C. Let's see if that's true. Do I have side A? I do have side A. And do I have side C? I do have side C. So that's the one that I'm going to use. So remember, we use the letter K for area. So K equals 1/2 A and little c times sine of big B. Alright, so basically now all we have to do is just substitute. And remember that I like to use, instead of 1/2, I actually like to use 0.5. So 0.5 times my A, which is 7, times my C, which is 3, and of course sine of 63 degrees in 10 minutes. Now that 63 degrees in 10 minutes shouldn't scare you, because I believe we've done an example like this as to how to input it in your calculator. Okay, so the first thing we should do is let's just go to our calculator, make sure that our our mode is in degrees, ours is correct. So I'm going to type it in, 0.5 times 7 times 3 sine of 63, 63. Then I'm going to press the second button, and I'm going to press the button that says apps, which is around here, somewhere around your calculator, because what I really am going to get is from pressing for it to get the angle. So you're going to press the button that says apps, and you're going to press number 1, because 63 right after that is the little degree symbol. And then I'm going to type in 10, and then go back to second, hit the apps button, and this time I'm going to scroll down to number 2, because that's my minute symbol, and press enter. Close my parentheses, and I get my area to be 9.369 9.369 units squared. Okay, if it were inches, of course it would be inches squared, but in this case we're not given any units, so any dimensions, so we'll just say it's units squared. Okay, that's area. Let's look at number 13. Number 13 is saying find the area of the triangle, and we have A is equal to 61 degrees, or angle A is equal to 61 degrees. Little a is equal to 4.3, and little b is equal to 4.3. Now what's special about this is our sides. We have two sides that are equal. So if you think about it, let's go back to geometry. If you have a triangle in which two sides are equal, that is called what kind of triangle? It's called an isosceles triangle. That's right. So let's go ahead and draw ourselves an isosceles triangle. And remember, the definition of isosceles is two sides are equal. And in this case, we are given two sides that are equal. But first, we're going to go ahead and just label our triangle. How about that? Because, of course, we want to do that first, and we want to do it correctly. So A is here, B is here, and angle C is here, up at the top. So across from angle C here, we have little c right here. Across from angle B, we have little b right here. And across from angle A, we have little a right here. Okay, so the sides that were given to us were B and A, and those were each 4.3. Keep in mind we're looking for area, so it's going to be about the same process as the one before. And B is equal to 4.3. And then it says that angle A is 61 degrees. Now here's the tricky part, because if you remember your geometry, if two sides are equal, then their opposite angles also have to be equal. So in other words, this angle has to be equal to this angle. So in other words, angle B is also 61 degrees. Well, since I know two angles of a triangle, I can go ahead and get my third one. So basically I have to say 61 plus 61, and that gives me 122. And then I subtract it from 180. So 180 minus 122. Okay, let's see what that gives me. That gives me 58. So angle C is 58 degrees. So I'm going to place it up here. And the reason why I solve for angle C is because I'm going to use that formula for area, which says, let's see, let's look at our area formula. 1/2 AB sine of C. If we were to use the other ones, we couldn't, because they both require you to know side C, and we don't know that. So we had to use this one, and in order for us to use that one, we had to first find angle C. Okay, so let's go back and basically have our formula. So K equals 1/2 AB sine of big C. Okay, so we have really K equals 0.5, because I don't like to use 1/2, so 0.5 times A, which was 4.3, times B, which was also 4.3, times sine of big C, which happened to be 58 degrees. Okay, so if you type all of that in, let's check. So we have 0.5 times 4.3 times 4.3 times sine of 58 degrees. So then we have 0.5, 4.3, 4.3 sine of 58. So we have 7.840 units squared. So that's our answer for our area. K equals, okay, let's see what we got. 7.840 units squared. 7.840 units squared. Because we're discussing area. Okay, so that's our answer for number 13. Now let's go ahead and find number 14. If you look at number 14, it says find the direction angle of the vector. So let's take a look at it right quick. You're given a vector and IJ notation. So let's change that into component form. So right quick, I will go ahead and click this one into a new one. The component form of vector V, which is given to us, is really (3, -2). Remember, the I comes first and then the J comes second with the sign in front, if there is one. Okay, so now direction angle, let's basically find where that is on the X and Y axis. So we have go 3 over, so we have, use a different color, 1, 2, 3, and then down 2. So it seems like we are in the fourth quadrant right here, and I'm going to stem my vector from the origin. Okay, and I will create a right triangle with respect to the x-axis. So now we're going to basically just discuss alpha over here. So this little angle in here is called my alpha. And with respect, we're just talking about distance. So the distance from the origin to here is going to be a 3. And the distance from here to the bottom right here to the tip of my vector, that happens to be 2. Now we've had questions like these in the previous test that you just took. With respect to alpha, this is opposite, and this is adjacent. And what trig function involves opposite and adjacent? That's tangent. So we have tangent of alpha is equal to 2 over 3. Remember, SOHCAHTOA, tangent is opposite over adjacent. Okay, so then I don't want alpha, I don't want tangent of alpha, I want alpha. So we have to take the inverse. So alpha is equal to the inverse of 2 over 3. Which now, if you type in your calculator, let's check to see what it is. Alright, so we have second tangent 2 over 3. And we get our answer to be 33.690 degrees. However, that's not what I want because that's not my actual answer. If you remember correctly, theta is from the positive x-axis, which starts here, all the way counterclockwise to your vector. So in other words, since I'm in quadrant 4, what I need to do to get theta is basically say theta is equal to 360 degrees minus 33.690 degrees. And if you type that in your calculator, you're going to get your answer for theta, which is the correct one. So we get theta is equal to, so let's see, 360 minus 33.690. And we get theta is equal to 326.31 degrees. 326.31 degrees. And that is our answer for theta. That's my direction angle. Okay, 15, A and B. Those are practice. I know some of y'all don't like to some of those, but actually they're pretty simple once you do them. Okay, so let's start with 15A. I'm just going to go ahead and start. I'm not going to write the vectors because they are already in component form, so there's no need for me to do anything to them. So I'm basically going to find 15A first. Let's take the A one. The A wants you to do U dot product with V times vector W. So the first thing you want to do is parentheses, PEMDAS, always follow your order of operations, and take U dot V. And that's what I'm going to do first. So I have U dot V, which is what I'm going to do. So in other words, I have my U happens to be 2, -1. And I'm going to dot product it with my V vector, which happens to be 3, 5. That's a 3. So 3, 5. Okay, now remember the meaning of unit vector or dot product is first component times first component, and then second component times second component. And then you add those together. So let's see, we get 6 plus a -5. Remember, if you do not know how to add or subtract in your head, use that calculator, because some of y'all made simple mistakes on your last test just because you were trying to do it in your head. 6 plus -5, or in other words, 6 minus 5, is equal to 1. So that one came out to be pretty nice because now I say 1 times my W vector. And in other words, anything times 1 is itself. So I don't even need to do anything here because I really am just left with 1W is the same thing as just W. So in other words, I just write my vector W, which happens to be -4, 2. And again, the reason I didn't do that is because if I were to multiply 1